Hello guys, welcome back to DSA playlist by 2am Coder. From this video onward, we are going to discuss about sorting techniques. We will see selection sort, insertion sort, bubble sort, quick sort and merge sort as well. But in this video, we will see the selection sort. So without further ado, let's get started. So guys, let's consider this is the array and we are going to sort this array using selection sorting technique. Now before going to the code, let's understand how selection sorting actually works. So basically in the selection sort, we find the minimum value in the array and we swap it with the first position so that the least value comes in the first position. And we will do the same thing with the rest of the array. The minimum value in the array is 1. We will swap it with 0 value. 9 will come here and the 1 will jump to the first index. And we will do the same thing with the rest of the array and try to find the minimum value and again put it in the index value 1. So let's write the steps we are going to follow to find the minimum value and sort the array using selection sorting techniques. Step 1 will be find the minimum value, or you can say index of minimum value. So basically we need to find the index where the minimum value present. Okay, we don't need to store the minimum value, but we need the index where the minimum value is present. So in the first iteration case, we consider index value 2 where the minimum value lies, which is 1. Okay, step 2 will be swap the minimum index value with first index. So once we swap the minimum index value with the first index value, we will have the minimum value in the first position. So that particular position will be sorted. Step 3 will be increase the index value, or you can say shorten the array, so that we can apply the same logic in the rest of the array to sort that particular portion. Now to apply this logic, we need to find the minimum value, and to find the minimum value we need one temporary variable, or you can say one key variable, where we will store the minimum value index. So initially we will assume that the minimum value is the first position itself. So we can write min here. We need two more pointers, which is I, which is required to hold the starting point of the array, and we will need another pointer called j. With the help of that, we will check the each iteration value whether it is greater or lesser than the minimum value. So the core logic is we need to check if array of min, or you can say if array of j, if it is less than array of min, because initially we assume that min is the minimum value in the array, and we will check with the j. If anything comes lesser than the minimum value, we will change the min value with the j value. Okay, so initially array of j is 2 and array of min is 9. So you can see the minimum value j has the lesser value than the min value. So now we can update the min value with the j value. It will come here. Now again with this we will move to the next index. Now since we are moving and we are checking, so for that we need a loop, right? So let's write a loop here. This is for j and it will start from always I plus 1. As you can see, we are checking with the I value, right? That means the min value. So we need a j value with I plus 1 as the starting value. It will go till array dot size minus 1. Okay, now array of j, it is lesser than array of min. Yes, it is lesser than the value of min, so we will update the min value with the j value. Again, we will move the j to the next index. We will check the same condition. It is not lesser than the min value. We will move it to the next index. Again, it is not lesser than the min value. Move it to the next index. Move it to the next index. Move it to the next index. Again, move it to the next index, and we'll keep moving until we reach the end. Once it reaches the end, we need to swap. So once we come out of this loop, we need to swap this, because what we are saying in the first step, we need to find the minimum value index. Now we have the minimum value index as 2, and we have to swap this particular value with the first position. Okay, so the first is nothing but I. Swap array of I with array of min. So with this step, you will have the minimum value in the first position. It will come here and 9 will go here. After swapping the value, this iteration is completed. We have to increase the value of I. So since we have increased the value of I, that means we need another loop, because we will keep increasing the I value until the end of the array. For that, I will be 0. It will go till size minus 1. Okay, now we are saying initially we assume that the minimum value will always be the first position value, right? So for that we can mention min as I initially. Okay, so min value will come here, and j value will always be the j I plus 1 initially. It will come here. Now again we will check if the array of j is less than array of min. No, it is not. Move it to the next index. Check again. It is not. Move it to the next index. Check again. No, it's not. Move it to the next index. Move it to the next index. Keep moving until it reaches the end, because none of the value are lesser than 2. So it reaches the end. Once it reaches the end, it will come out of the loop, and we need to swap array of min with the array of I value. Since it is at the same position, no need to swap it. Anyway, if we swap it also, it will not make any difference. Since we have swapped it, we will move the I value to the next index. As soon as we move the next I value to the next index, we assume that the minimum value will always the first position, because now you can see this particular array is now sorted, and now we need to sort this particular array. Okay, so now this is the array we have, and we will apply the same logic here. So initially we consider the minimum value as the first value itself. Again, the j value will be I plus 1. J will come here, and again we will check if array of j is less than minimum. Yes, it is. We'll move the min value to the next j value. Move the j to the next index. Again, j is less than the min. Min will become j. We'll move j to the next index. No, it's not less than min value. move it to the next index, move it to the next index. Now j value is less than the min value, move the min to j, and we will move the j to the next index. No, it's not less. It is lesser than the min value, move the min value to the j value, and we will keep moving until it reaches the end. Now again, after reaching the end, we swap array of I with array of min. Here we will swap this particular value with I value. So for that, just write 3 here, and this will replaced with 9. Now we have swapped the value. Again we need to increase the value of I. Since this particular portion is sorted, we have moved the I value to the next index, and initially the min value will the first position and j will be always I plus 1 initially. Again we will check, it will come here because 6 is lesser than 7. It will move to the next index, move to the next index, move to the next index. Again 4 is less than 6, so min will become 7 here. Move it to the next index. It's not lesser than 4. Move it to the next, move it to the next, move it to the next, and then once j reaches the end, we need to swap min value with the I value. It will become 4 here, and this will become 7. After swapping, we need to increase the value of I. So as you can see, this particular portion is sorted now. Again the min value will be I initially and j will be I plus 1. Again we need to check 12 is not less than that, move it to the next, move it to the next. Now this is the less than the min value. We need to shift this min to index 8. Move it to the next index. Again, because it's not lesser than 5, it will reach to the end. Now again we need to swap array of I with array of min. This will become 5 and this will become, what was the value here? 6. This will become 5 and this will become 6. After swapping, we need to increase the value of I. It will come here and the min value will become I. J will become I plus 1. Again we will check, move it to the next index. 7 is less than 12, so min will come here, j will come here, and j value is less than min value. It will come here. After changing the min value, we will move the j index. Again move it because these are not less than 6. It will reach to the end, and as soon as it reach, we will swap. So this will become 6 and this will become 12. After swapping, increase the value of I, and as you can see, this particular portion is sorted now. Min will become the I value initially and j will become I plus 1. Now again the value of j is less than the array of min value. 7 is less than 15. We will update the min value with the j value. It will move here and we will move the j value to the next index. It's not less than 7, so move it to the next. It's not less than 7, so move it to the next, move it to the next, and move it to the next. It reaches to the end. Again we will swap min value with the I value, so 7 will come here. 7. 15 will come in next index. So after swapping, we need to increase the value of I. So as you can see, this particular portion is now sorted. We will apply the same logic again. Min value is equal to the I here and j is I plus 1. Again 12 is less than 15, so it will come here. Move the j to the next index. J is less than min value, yes, then change the min value as j value. Move the j to the next index and again check it is not less than that, it is not less than the minimum value. Move it to the next index. Once it reaches the end, we will swap the min value with the j value. 9 will come here and 15 will come here. After swapping, we need to increase the value of I, and initially min will be the I value and j will be always I plus 1. Again, we will apply the same logic. J value is greater than min value, so we will move it to the next index. Again, it is not lesser than min value, move it to the next index, move it to the next index. As soon as it moves, we will swap, so it is in the same index. That won't make any difference, so we will simply move the I to the next index and min will become the I value initially. So this particular portion is now sorted. Now you can see j will become I plus 1. Again we will check if j is less than min. No, it is not. Move the next index. Again move to the next index. Since this again it is on the same position, will not make any change. Move the I value to the next index and min will become I value. This will also be shortened. So as you can see, we are shortening the array by increasing the value of I. That's why I have written here increase the index value or shorten the array. So in this case as well, j will become I plus 1 as per this logic, and j value is not less than min value. We'll move here and again it will swap the same index. This will not make any difference. This will come to the next index and again we will short this array, and as you can see we need j value as always array of size minus 1. So as you can see here we have written I plus 1. J will be I plus 1, which is 12. So this will break the loop and again I value will also increase and this will come here and the loop will break. So at the end you will have a sorted array. As you can see, now this array is sorted. Now let's code this logic in IDE. Let's quickly create one package and a class for selection sort. So let's consider this is the array and this is the same array which we had here earlier, and we will sort this array using selection sorting techniques. First we will print this array. Okay, so let's print this array. Now this is before sorting and after sorting. So before sorting and after sorting will be same because we are not calling this method. And before printing after sorting value, we will call this selection sorting. We will pass the array, and we need to write that same logic here. So we will simply copy this and paste it here. Now since it was an algorithm, we need to convert this into the actual code. Int I equals to 0, and this will go till I should less than array dot length. I plus plus. This will be semicolon. And since I said we need minimum value, right, and we need to update the minimum value always, so this will be the minimum value initially. Let's change it to j I plus 1. This will be size minus 1, and then j plus plus. Array of j, if it is less than min value, we will update the min value, and at the end we need to swap. So I think for swapping we can create one more method, or we can simply write this swap logic here itself. So I'll write the swap logic here quickly. Okay, this way we have swapped the value. Let's run the program. Yeah, as you can see, this is working. The time complexity of this logic is n square, big O of n square, because we are iterating n into n times with the help of two for loops. So this is not quite a best approach, and the best approach is quick sort or merge sort. We will see it in the next upcoming videos. Till then, bye bye, take care. If you have any doubt, you can write your doubt in the comment section. I'll try to resolve that in upcoming videos, and just stay tuned. Subscribe to my channel and share it with your friends. Bye bye.